transmission line. A transmission line is a two-port network connecting a generator circuit at the sending end to a load at the receiving end. That is, it is going to transfer energy from one point to another. Takes place through either waveguides or transmission lines. A transmission lines always consist of at least two separate conductors between which a voltage can exist. But the waveguides involves only one conductor. For example, a hollow, rectangular or circular waveguides within which the wave propagates. Transmission lines are means of conveying power from one point to another. That is, there are some common types of transmission line, that is coaxial cable, two-wire line, parallel plate line, microstrip line and waveguides. In general, we are going to use only two types of transmission lines, that is either you are using a parallel wire that is called as balanced line, or by means of a coaxial line that we can call it as an unbalanced line. Examples of transmission line, in which places we are going to use the transmission lines, that is, it is communication, it carries that telephone signals, computer data in LAN, TV signals in cable TV network, telegraph signals, antenna to transmitter link. So basic transmission line, it transmits a signal from sending end to a receiving end, that is a signal source to the terminal load. Any complicated network with a terminal voltage and current are indicated as shown in the figure. A succession of n networks are in cascaded. It can be, that is, to study the behavior of a transmission line, a transmission can be considered to be made up of a number of identical symmetrical T sections connected in series or in terms of pi connections. If the last section is terminated with its characteristic impedance, the input impedance at the first section is Z0. Each section is terminated by an input impedance of the following section. What are all the parameters we are going to use here? That is, we call it as a distributed parameters. We use the following distributed parameters to categorize the circuit properties of a transmission line. Since each conductor of a transmission line has a certain length and diameter, it must have resistance and inductance. Moreover, the two conductors are separated by a dielectric medium, say air. Therefore, there must be a capacitance between them. These dielectric between the conducting wires may not be perfect, and hence a leakage current will flow through that capacitance between the conductors. So these four parameters, that is resistance, inductance, capacitance and conductance, all distributed along the lines are known as the distributed parameters. So R is defined as a loop resistance per unit length of the transmission line. It is measured in ohms per meter. Next, inductance. Inductance is defined as the loop inductance per unit length of a transmission line. It is measured in henries per meter. Next, capacitance. Capacitance is defined as a shunt capacitance per unit length between the two transmission lines. It is measured in farads per meter. G, conductance. It is defined as the shunt conductance per unit length between the two transmission lines. It is measured in mhos per meter. So characteristic impedance. We know that the ratio of voltage to current, we can call it as an impedance, that as per the Ohm's law, the voltage is directly proportional to the current. The proportionality is replaced by a resistance. Since it is an AC, we can call it as an impedance. From transmission line model, that Z0 is represented by root of R plus J omega L divided by G plus J omega C. As we have seen already, all the parameters are resistance, L inductance, G conductance and C capacitance. So to see the performance of a network, we have the performance is input current by output current. That is, if the ratio of the voltage to current at input and output of the network are equal, then we can call it as, that is, I1 by I2 is equal to V1 by V2. It is propagation constant gamma. The magnitude ratio does not express the complete network performance. It is a phase angle between the current being needed as well. The use of the exponential can be extended to include the phase current ratio, that is I1 by I2 is equal to e power gamma, where gamma is a complex number defined by gamma is equal to alpha plus j beta, where I1 by I2 is equal to e power gamma, that is e power alpha plus j beta. So A is equal to I1 by I2, which is called as e power alpha, and beta is e power j beta. So with Z0 termination, it is also true when V1 by V2 is equal to E gamma. The term gamma has been given the name as propagation constant, and alpha is called as an attenuation constant. It determines the magnitude of ratio between input and output quantities. It is the attenuation produced in phase in passing the network. The unit of attenuation is neffers. Beta, we call it as a phase constant. It determines the phase angle between input and output quantities. If the phase shift occurs, it indicates the propagation of signal through the network. The unit of phase shift is radians. It can also be expressed in logarithmic, that is in decibels also.